Hello, all, and welcome to Death of the Universe. So, obviously, today we're going to be talking about the main theories of how the universe is going to end. So, let's get right into it. So, first, we need some basic information. The start of the universe is known as the Big Bang, and that was way back when the universe used to be all contained in a very, very small point. You could imagine it being be able to fit all the universe in your hand. Very, very dense, hot, heavy object. And it exploded into a massive quote unquote Big Bang. Now, the universe is 13.7 billion years old. So the Big Bang happened 13.7 billion years ago, and the universe is still expanding. Not only is it expanding, but it's also accelerating. And another important note to add for one of the theories is the average temperature of the universe, that all of it, including the space in between solar systems and stars, the average temperature of the universe is 2.73 Kelvin, or about negative 270 degrees Celsius, or about negative 455 degrees Fahrenheit. Now, the first theory of how the universe is going to end is probably I'd say the classical idea, or the first, most, I don't want to say most logical idea, but this is probably the longest or first idea thought of that has a general consensus out of the big three of how the universe is getting. It's called the Big Crunch. So, what's the Big Crunch? We have the Big Bang, start of the universe, and everything is expanding, right? Until the point that we have now. But eventually, the idea is that all the matter inside the universe, right? If you talk about all the stars, all the black holes, all the galaxies, the total summation of all of the matter and mass inside the universe is pulling on each other, gravity. So there's this idea that there's a maximum volume or a maximum limit to the expansion of the universe. It's expanding. The expansion is going to eventually slow down, and it's going to stop, and then it's going to reverse and start to contract in, because we have all this mass and matter inside the universe that's going to pull on each other. So eventually the universe is going to start contracting. As it's contracting, it's going to increase in temperature. So we know that the universe is 2.7 degrees Fahrenheit. Well, as the universe contracts, the space between galaxies and the space between stars gets smaller and smaller. The overall temperature of the universe is going to increase. So it's also going to make the universe very hot, to eventually things are going to start colliding with each other. Masses are going to be, there's going to be a higher concentration of mass and matter. So there's going to be more production of black holes as the universe continues to shrink down. And it's going to have a black hole. So eventually the universe is going to come all the way down to a singularity. And the idea is this is where the universe started. Now we're back where we started. And then we have the potential for another Big Bang. And the idea is that this is almost like a pulsation between Big Bang, maximum expansion, contraction back down to a singularity, another Big Bang. And you have cycles of the universe. So there's some theories that this is the third or fourth cycle or fifth cycle. We don't know, because this takes very, very long, and none of us or nobody is alive for the majority or for a good part of this venture. Getting to the second big theory. Now, there's a handful of theories. We're just going over the big three. My opinion, the big three. So again, we start off with the Big Bang. We have the expansion, and we have the present day universe. Now, this idea is a little different, to where there isn't a maximum expansion limit. This idea takes the philosophy, or takes the idea that the universe continue to expand infinitely. It's going to continue to get big, continue to get big. Now, because of the expansion, this causes gas in the distance between the distance between stars or solar systems to become very dilute, and the distribution or the concentration of matter in the universe is very, very low concentration. Now, going back to those temperatures, remember that the average temperature for the universe is 2.7 degrees Kelvin. As the universe expands, it's going to continue to cool down. Just like with anything we have on Earth. If you increase the volume with no external forces acting on it, you have something that's hot. If you increase the volume, the temperature will cool. Simple thermodynamics. Same concept with the universe. Imagine the universe as a system, and it started off really, really hot at the Big Bang, and it has expanded to the point now where it's 2.7 degrees, 2.7 degrees Kelvin, or negative 270 degrees Celsius, or negative 455 degrees Fahrenheit. As it continues to expand, that temperature continues to drop. Continues to drop so much where there's this concept called absolute zero. Absolute zero is in the Kelvin temperature scale. Whenever zero Kelvin is absolute zero. Absolute zero is when atoms no longer have motion. So to put into perspective, everything on Earth, everything that you're sitting around, even if it's a solid object, it's moving on the molecular level. If you were able to look at its individual atoms, they're vibrating at a certain frequency. Now, obviously, solids vibrate slower than liquids or gas, but they vibrate. Even ice, frozen water, still vibrates. Their atoms vibrate. Now, they vibrate slower than liquid water or water vapor, but they still vibrate. When you get to absolute zero, atoms no longer have enough thermal energy to move, because friction, movement, that is primarily heat released energy. When you have any type of movement, you're releasing heat, even if it's not a lot. If you have absolute zero, there's no movement whatsoever. There's no thermal energy being produced. You cannot support life at absolute zero. So the overall or average temperature of the universe reaches absolute zero, life cannot be sustained. It would be too cold for life to exist. There's no motion anywhere in the universe besides the expansion of the universe. But all planets, stars won't form, stars will be frozen, planets will be frozen. Life cannot exist. That's the big freeze. The last theory is the big rip. It's somewhat similar to the big freeze up to a point. Again, we're starting off with the Big Bang. We have the expansion. We have our present day universe. There's a continued expansion, but there is a limit. It's kind of a combination between the contraction or the big crush and the big freeze. Idealistically, it's a kind of a combination of two, because there is this maximum volume you can hit, but the universe will continue to expand past that point to where things are going to be ripped apart. So with this theory, it introduced the idea of dark matter, dark energy. So one of the reasons why we expected the universe to be decelerating in its expansion, but it's accelerating. And one of the ideas is that there's this dark matter that is producing this force that's accelerating. It's accelerating the universe in its expansion. As the distance between solar systems and stars increase, or as the universe expands, the more dark matter there is, and the more force the dark matter acts on the increasing the acceleration. So that, if that makes sense. Think about a balloon. You're blowing up a balloon, and you pushing air into the balloon is the dark matter forcing that acceleration. Eventually, the universe will get to a volume where the acceleration, the dark matter expansion will dominate the universe. So the forces holding in particle, the strong nuclear force, the weak nuclear force, gravity, dark matter force, the force of dark matter accelerating the universe will dominate and overtake even the force that holds protons and neutrons together, nucleus, and will start ripping things apart to where you have the Earth being pulled apart, galaxies being pulled apart, even atoms themselves will be pulled apart. And this is what's been called the Big Rip. Now, those are the three main ideas or three main theories of how the universe is going to end, but it's not happening anytime soon. It's believed that it's probably going to take another 22, 25, maybe 30 billion years before we see either of these happening. So we'll find out eventually, but not anytime soon. And so that's what I have for you guys. Let me know what you guys think, reviews. I don't know, reach out to me. But class is dismissed. Appreciate you for listening.